number 7, we have the definite integral from 0 to 1 of the definite integral from 0 to 1 of y over 1 plus x times y dx dy. Here, if I'm going to do this definite integral with respect to x first, I should be treating y as a constant. So I think of y as what has roughly the same shape, a 4 or something, or a g. So thinking of y as a constant, I think it is very nice here to use substitution. So what I'm going to do is I'm going to put in an equal sign. I have a nice way of writing substitutions. I write above the equal sign u, the new variable, is in terms of the old variable. I'm going to do 1 plus x times y. Now, for the sake of this inside integral, y is a constant. And so du, which by the way is du dx times dx, and du dx is simply y, right? The derivative of 1 is 0. The derivative of x times y with respect to x is y. Okay, so again, du is du dx times dx, and du dx is y. So, doing that, I have the integral from 0 to 1, and the other integral with respect to y, the integral with respect to x is going to change to a new variable, so let's be very careful. The new variable of integration is going to be u, so I shouldn't write dx again, nor should I write the limits of integration. Okay. 1 plus xy is simply u. 1 plus xy. And then y times dx, the old denominator, y times dx is actually just du. Okay. Now, that means my new numerator is 1, because y times dx, both those things turn into du. Now my limits of integration, u should go from somewhere to somewhere else. Well, when x was 0, u is 1. Right? Replacing x with 0, the lower limit of integration, gives 1 plus 0. And when x is 1, the upper limit of integration is 1 plus x times y, but with x replaced by 1. That's 1 times y, or just y. All right. Now, the antiderivative of 1 over u with respect to u is the natural log of u. That we're going to evaluate between 1 and 1 plus y. And remember, it is u that we are substituting with 1 and 1 plus y. And we have yet to deal with this integral from 0 to 1 with respect to y. Substituting in 1 plus y, we get that. And substituting in 1, we get that. The natural log of 1 is 0, so this term is simply going to vanish. Okay, so we're looking for an antiderivative of the natural log of 1 plus y. So let's simplify this guy. Definite integral from 0 to 1 of the natural log of 1 plus y with respect to y. Now, we're going to integrate by parts. Let's make the table for integration by parts. There's a secret factor of 1 right there, 1 times natural log of x. And the usual trick is to take that 1, you put it over here, and here you put the natural log of 1 plus y, and the derivative of natural log of 1 plus y is 1 over 1 plus y, while the antiderivative of 1 with respect to y is y. Okay, that leads us to product across the diagonal is y, natural log of 1 plus y, that we're going to evaluate between 0 and 1. And then we'll have a definite integral from 0 to 1 of the product across the bottom, y over 1 plus y. Okay. Now, this is not going to be too tricky to evaluate. Well, 1, replacing y with 1, we have a natural log of 2. And subtract what happens when you replace y with 0. You get 0 times natural log of 1, or 0. Here, things are going to be a little bit trickier. That is an improper integral. I suppose there's a variety of ways to do this. One of them, let's note that I used integration by parts in this equality. One of them is to replace y with another variable. In particular, I'll have u be 1 plus y. That way du is the same thing as dy. Remember, I like to write my substitutions above and below equal signs. There we go. Then the denominator is u, while the numerator y is u minus 1. And my new variable of integration is u. Du and dy are the same thing, so I replace the differential there. Okay. When y is 0, u is 1. And when y is 1, u is 2. All right, let's finish this thing up. That's natural log of 2 minus the antiderivative, rather the definite integral from 1 to 2 of 1 minus 1 over u du. Okay, little paper I have left. Natural log of 2 minus u minus natural log of u, this whole thing evaluated between 1 and 2. Okay, natural log of 2 minus, all right, first thing we got is u replaced with 2 minus natural log of u replaced with 2. Then we have minus for subtracting what we get when we evaluate it at 1. That's a plus overall. 1 minus natural log of 1, which is 0. Okay, so I see natural log of 2